Hello everyone, welcome back to another video. Today we're going to take a look at analytical geometry. These questions are from two papers. This one, question number 6, is from the September 2016 paper, and the one that we're going to be doing next is actually from the November 2016 paper. Let's take a look at it. Question number 6 says, in the diagram below, A, B, C, and D are the vertices of a quadrilateral. Quadrilateral means a four-sided shape. Question 6.1, calculate the length of BD. So let's make a note here. This is September 2016. Now, we can calculate the length of BD by using the distance formula. Now, I'm going to write down the coordinates just so it's easy for us to work with. So B is minus 2 and 7. D is 0 and 1. So BD is going to equal, now I'm going to label this. This is going to be x2 and y2. That's going to be x1 and y1. It doesn't matter which one you mark as x2 and x1 or y2 and y1, as long as you keep it consistent. So formula, as we know, is x2 minus x1 all squared plus y2 minus y1 all squared. Now we can go ahead and substitute. So negative 2 minus 0 all squared plus 7 minus 1 all squared. That is the square root of negative 2, that's 4 plus 6, that is 6, and that gives us the square root of 40. So BD, this diagonal, has a length of square root of 40. Let's move on. Question 6.2. Show that AC is equal to BD. Now, to show that two lengths are equal, we just need to work out the length of the other side. So I'm going to write down the coordinates again for AC. So A is 2 and 5. C is negative 4 and 3. I'm going to go ahead and label them. This is going to be x2, y2, x1, y1. And so I'm not going to write the formula again. Instead, we just go ahead and substitute. So 2 minus 4 is 2 plus 4 all squared. And plus 5 minus 3 all squared. And that's 6 squared plus 2 squared, that is the same. It gives us the square root of 40. And there we've shown it. Question 6.3. So let me just fill this information is like this. That is square root of 40. And they said, next one, show that the coordinates of M, the midpoint, is minus 1 and 4. So midpoint of BD. We can use the coordinates as we've done before. So M is going to be x2 plus x1 over 2, and then y2 plus y1 over 2. Now we just substitute. You have minus 2 plus 0 over 2, and 7 plus 1 over 2. That simplifies. M is therefore minus 1 and 4. Now question 6.4, calculate the gradient of AM. So let me just write this down. So M is minus 1 and 4. Now the question says calculate the gradient of AM. So AM, okay. So I'm going to write down the coordinate for A is 2 and 5, and M is minus 1 and 4. I'm going to label them. That's going to be x2, that's going to be y2, that's going to be x1, that's going to be y1. The formula for gradient, so the gradient of AM is equal to y2 minus y1 over x2 minus x1. So it's going to be 5 minus 4 over 2 minus 1, so 2 plus 1. So 5 minus 4 is 1, 2 plus 1 is 3. So the gradient of AM is 1 over 3. Now let's take a look at the next question. It's question 6.5. So 6.5 says, prove that AM is perpendicular to BD. So what we need to do here is we need to work out the gradient of BD. So the coordinate for B is -2 and 7. The coordinate for D is 0 and 1. Let's go again and label. So that's going to be x2, y2, x1, y1. Then we can work out the gradient for BD. We don't need to write the formula again. It's going to be 7 minus 1 divided by -2 minus 0. 7 minus 1 is 6. 6 divided by -2 is -3. Now, if we multiply the gradients together, and if we get -1, then we know that the lines are perpendicular. So we can say that the gradient of AM times the gradient of BD. So AM is 1 over 3 times BD is -3, and that gives us -1. Therefore, AM is perpendicular to BD. And then the last one, question 6.6. So we can write here AM perpendicular to BD. So we can say that that's 90. That means that's 90, that's 90, and that's 90. Then that is equal to that. Yeah, okay. Now they want to know, write down giving a reason what type of quadrilateral ABCD is. So ABCD is going to be a square. And why is it a square? It is because the diagonals are equal and the diagonals meet at, or they bisect at 90 degrees. Okay, so that's the first paper. Let's take a look at the next one. So this is the November 2016 paper 2. So question number 3 reads, show that a triangle ABC with vertices A, B, and C, they give us the coordinates, is an isosceles triangle. So 3.1. So let's just sketch this out. So A is 1 and 1, so approximately there. B is 3 and 6, so that's A. B is 3 and 6, so somewhere there. And then C is 6 and 3, so somewhere here. Again, I'm just estimating. Okay. Now, to show that something is an isosceles triangle, remember, an isosceles triangle is a triangle in which two sides are equal. So what we need to do is we need to work out the length of the sides, and if two sides are equal, then we know it is an isosceles triangle. So let's go ahead. Let's go and calculate the length of AB. Now I'm not going to write out the coordinates again and mark them as x2, x1, just in the interest of time. So I'm going to go ahead here and just go straight into the formula. So AB is going to be 3 minus 1 all squared plus 6 minus 1 all squared. We can then simplify that as 3 minus 1 is 2, 2 squared is 4, plus 6 minus 1 is 5, 5 squared is 25. And so AB is the square root of 29. And that's its length. We don't need to simplify it. Now let's go ahead and work out the length of AC. So AC, again, don't need to write down the coordinates. Just substitute here. So AC is going to be 6 minus 1 all squared plus 3 minus 1 all squared. That is equal to 6 minus 1 is 5, 5 squared is 25. And plus 3 minus 1 is 2, 2 squared is 4. And here we go, we have the square root of 29. So since AB is equal to AC, we can say therefore triangle ABC is isosceles. So as easy as that, 4 marks. Let's take a look at question 3.2. In the diagram below, ADCB is a kite, and they've given us the coordinates for A and B. AD is equal to DC. So let's mark that off. So AD is equal to DC. So this is equal to that. And AB is equal to BC. So AB, so that is equal to that. D is a point such that AD is parallel to the x-axis. Okay, and AD is 5 units. So this is 5 units. So if that's 5 units, this must be 5 units as well. CD is perpendicular to the x-axis, okay? The diagonals intersect at P, okay? Now, 3.2.1, show that the coordinates of C are 8 and 0. All right, so we can clearly see here that point C lies on my x-axis. So if it lies on the x-axis, we know that y is going to be 0. Now we want to figure out how do we show that the x-coordinate is 8. And we've got to use this and this. So if this point has an x-coordinate of 3, if we move 5 units to the right to get to D, D and C are going to have the same x-coordinate because CD is perpendicular to the x-axis. So in other words, D is going to have an x-coordinate of 8 and something. And because of that, C is also going to have an x-coordinate of 8. And that's it. Show that the coordinates are 8 and 0. All we needed to do here is we're going to say, so 3.2.1, C lies on x-axis, therefore y equals 0. And then we can say that 3 plus 5 and 0 is the coordinate for C. C is going to be 8 and 0. Let's move on. Question 3.2.2. Write down the coordinates of point P. Okay, so point P. How do we work out the coordinate for point P? Okay, here we go. So we know the coordinate for A and we know the coordinate for C. The coordinate for P is going to be the midpoint of AC. Right? Because remember, one of the properties of a kite is that this length is going to equal to that length. So P is going to be the midpoint. So to calculate midpoint, P, again, we don't need to write the formula. P is going to be 3 plus 8 over 2 and 5 plus 0 over 2. So P is going to be 11 over 2 and 5 over 2. So 11 over 2 and 5 over 2. So 11 over 2 and 5 over 2. Okay. Calculate the gradient of the line BD. So to calculate the gradient of BD, we need the coordinate for B. We do have it. And we need the coordinate for D. We know partially. We know that the x value is 8. Now to figure out the y value is not that difficult. Because they tell us that this line AD is parallel to the x-axis. So they tell us here AD is parallel to the x-axis. It means that the y value is going to be the same. So in other words, this coordinate D is going to be 8 and 5. So that's also very important. So now that we know the coordinates, we can work at the gradient. So let's go ahead here. Let's draw a line 3.2.3. So the gradient of BD is going to equal 5 minus minus 4, so 5 plus 4, over 8 minus minus 1, so 8 plus 1. So 5 plus 4 is 9, 8 plus 1 is 9, so 9 over 1 is 9 over 9 is 1. So the gradient of BD is 1. 3.2.4, calculate the length of the line AC. So to calculate the length of AC, we can use our distance formula. So AC is going to equal the square root. Now I'm going to go with 8 minus 3 all squared plus 0 minus 5 all squared. And that's going to equal 8 minus 3 is 5, 5 squared is 25, plus 0 minus 5, that's negative 5, negative 5 squared is 25, so it's going to be the square root of 50. So AC is the square root of 50. That means, okay, yeah, that's fine. And then 3.2.5, the last question, calculate the area of the kite. Okay, that's not a problem. So now we need to remember how to calculate the area of a kite. The area of a kite, let's use blue. So the area of a kite is equal to half diagonal 1 times diagonal 2. So half, we know diagonal 1, AC is 50. So AC is square root of 50. And then times, we need to work out the length of the other diagonal. So the other diagonal is BD. So we need to work out the length of BD. So BD is going to equal the square root of, let's go with 8 minus minus 1, so 8 plus 1 all squared, plus 5 minus minus 4, so 5 plus 4 all squared. So that is the square root of 9 squared is 81, plus, again, 9 squared is 81. That gives us the square root of 162. So that's the length of the other diagonal. So the square root of 162. And so if we put this now in a calculator, half of the square root of 50 times the square root of 162, we get 45 units squared. And that's our answer. Thanks so much for watching. Hope you found this useful. Don't forget to like, share, and subscribe. And I'll see you in the next one. Bye-bye.